powerful. What we're going to do is actually look at, this is English and French. First and foremost, before we go on to English and French and all that, you know, the Latin alphabet. So when you look at the characters right here, right, the characters of this is the Latin alphabet, right? Latin characters. Now this alphabet is actually used by a bunch of different languages, and I have a list here. Languages that use the Latin script are languages such as Croatian, Czech, Danish, Dutch, English, Estonian, Finnish, French, Gaelic, Scottish, German, Hawaiian, Irish, Italian, Judeo-Spanish, Latin, of course, Latvian, Lithuanian, Slovak, Spanish, Swahili, Swedish, and Welsh. And we're going to go over a few of these, right? So this Latin alphabet is used in all these different languages. Now, all those languages have different syntax, have different orthography, have different spellings of words, have different inflections in how you speak words. Some have genders, some don't. All of that sort of stuff, right? All of those different tongues, right, that are spoken all across the world have a unifying concept that is at the base of those languages, and that is the actual architecture of the alphabet itself, right? Basically what we did is we're looking at English and French, and we're looking at the words 0 through 9 and 1 through 10. English, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You put the Gematria values to those 10 words, it equals 180. You go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You put the sevenfold cipher to those 10 words and it equals 180. We already covered it's the gem of tri. It's the precious stone of 3. Now we go to French male. Now this is taking the distinction that it's male. And you get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this equals 181. Pretty close to 180, right? Okay, let me stop you right there. And I want to go to one thing that I actually basically just learned, is something I was employing, but I didn't even realize that there was actually a terminology to it, and it's called the rule of Colel. And the rule of Colel is the rule according to which one digit may be added to or subtracted from the gematric value of a word. So it's this idea that when you get a value, like for instance 180, you can add or subtract one number to get your result, in other words, right? And there's a whole reason why that. There's a whole, I think, theological reason, spiritual reason for why this is. And let me just say in short, it's because you have to include yourself in the math. You have to include yourself in the math because you have to include the person that's doing the math in order to do the math properly. So that's this idea of adding and subtracting 1. That's a whole lecture. But for instance, French male 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 181. In other words, if you use the rule of Colel, that's 180. Look at the French male 1 through 10 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I was saying that wrong. Anyway, boom, right there, 180. French male 1 through 10. English 0 through 9, 180. French 1 through 10, 180. French male 0 through 9, 181. With rule of Colel equals 180. French male 1 through 10 equals 180. Now look at that French female 0 through 9 and French 1 through 10. I want to show this thing real quick. Now, when two French, a male and female, so if you give the distinction for the male and un for female, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equals 180 for a male. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equals 185 for a female. That means when a male and female join hands in the French language, it equals 365. Well, what is that? It's the number of days of the solar year. So there you go. English, French, seems to work with this septenary cipher, right? Let's go to Spanish. Spanish. Oh, please don't make me speak these Spanish words because I will just butcher them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm sorry. Look at Spanish female, 0 through 9, 181. Spanish male, 0 through 9, 180. So with the Spanish female, you got rule of Colel, that's 180. Spanish female 1 through 10, 181. Rule of Colel, that's 180. Spanish male 0 through 9, that's 180. Spanish male 1 through 10, that's 180. Spanish 0 through 9, just regular Spanish, just if you speak it, 0 through 9 equals 182. Like, 0, 1, 2, 3, 4, 5, 6, 7. I'm sorry, I'm butchering that. Spanish 1 through 10 equals 182 as well. Look at that. Now, So if you use the rule of Colel on the Gematria total of just regular Spanish, 180 or 182 there. So let's say you subtracted one. That would give you 181. Okay, let's look at the properties of the number 181. It's the 42nd prime, with 42 being a number you all know so well. At least I hope you know that number pretty well by now, right? So it's the 42nd prime. You add the divisors of 181, it's 182. The divisors, it's the prime, so it's 1 and 181. That's 182. So look at that. Look at this. That's Spanish. This is English and French. Okay, let's go to German. German, pretty much the same thing. Now, I'm going to show these two because there's a bunch of different ways that you can actually, spell out these words. You can use it with the umlaut or without the umlaut. And I'm showing both here. Like I said, you can pause this video and double check all this math yourself, but you can see right there. I mean, let's I'll just name a few here. German male 0 through 9 equals 180. And you can even, if you combine the German male 0 through 9 and the German female 0 through 9, you'd have 365 days again. Because German male 0 through 9 is 180. German female 0 through 9 is 185. That's 365. Right? And so this is with the umlaut and without. Is his name? Yes, Andrew Davies. He sent me this. He said, "Hey, yeah, I did 0 through 10, right? 0 through 10, this is 180. That's Welsh." So the why I'm showing all this right now is that, of course you would have to speak that language, number one. But you would have to go into every single one of these languages, like I did that whole list: Croatian and Gaelic and Irish and Italian and blah blah blah, Slovak and all that stuff. You'd have to go into all those different languages and do this and find out what happens. But I mean, the statistical possibility that all of those numbers would even be around 180 is. It doesn't even make sense statistically. I'll just go over the stats really quick. I know this may be some kind of boring math, but I want to make the case here to show how there's no way this is pareidolia. There's no way this is apophenia. There's no way that this is me just putting a bunch of numbers together, And like I said, I would challenge any linguist or mathematician out there in any university level that's probably getting paid hundreds of thousands of dollars a year to ignore shit like this. I would challenge any of those people to say that this is some statistical anomaly. Let's do the stats on it as far as I understand, okay? So for instance, when you look at this cipher right here, you look at this, where am I here? Oh, where am I? Haven't done this in a while. Cipher right here, right? You have 1, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1. And you have it twice. So you have 1, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1, A through M, the same thing, N through Z. So you have, if you added this up, 1 through 7 and back down to 1, if you add this up, it's 49. Well, you're doing that twice, right? So you'd have 49 plus 49. Like I said, this is kind of boring math, but I want to show this because it's just insane. This is 98, right? Well, there's 26 letters of the English alphabet. So what you would do to find the average number that you would give to each letter of the alphabet, you would do this: 98 divided by 26, and you would get roughly about 3.8. But roughly about 3.8, right? So if you took, there's 40 letters in 0 through 9. So if you count the number of letters in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 that you say in English, you would have 40 letters, right? And that's roughly approximately how many letters you have in you could say 40, some say 38, you could say 40, you could say 42, roughly around, depending on what language you speak, you're going to have about that many letters to speak the words 0 through 9 or 1 through 10. So you have about 40 letters, right? Well, what you would do is take 3.8 times 40. And so therefore, statistically, on average, if you just use this cipher, statistically, if this wasn't designed, you should come out to about all of those ciphers coming out to roughly about 152. 150, 160, somewhere around there. In other words, that if you just did a statistical analysis on everything that I just presented to you, if this was just a bunch of hoobaloo and it was just a bunch of, wasn't designed and wasn't, there wasn't any intention there, right? You would roughly come up with numbers something like this: 150, 160, you could even go 165, maybe even less than 150, but roughly you would get there. You wouldn't get your mean or average number being 180. And 180 in Welsh, 180 in German, 180 in Spanish, 180 in French, 180 in English in multiple instances. That shows design. It's a simple statistical analysis. This is, as far as I understand it, that proves that. I mean, this is some. Who did this? Who's encoded this stuff? Why? Well, the who is a big question. The why I'm trying to explore on this channel. That's what we're trying to do here.